Hey everyone, welcome back. And today we'll be doing another Leetcode 338 counting bits. This is an easy one. Given an integer and return an array such that for each I in ANSI is the number of ones in a binary expression. So what they are trying to say is if we give you a number 2, you will compute the binary one. First of all, seeing their binary, if they have one, how many one they have one bits in them. So 0 has 0, 1 has 1, and 2 also has 1, like you can see here. And also for the 5, 0, 1, 1, 2, 1, 2, like you can see here. And that's it. Now let's understand how this will work. So starting from the 0 and till the 8 we will be seeing. So you can see 0 has 0, 1 bits, 1 has 1, 2 has 1, 3 has 1, 3 has 2, 4 has 1. So 5 has 2, and if you look closely, the pattern is being repeated. The most significant bit is added by 1 to the very left, but the pattern is repeating like 0 1 and 1 0 to 6, 11, not 11 but 1 1 in 7 and 3 and 8 and 4, not 8 and 4, 8 and 0, adding the most significant digit to the very left and not digit bit. So how this is working is we are adding like 1 plus to our most significant bit to the very left, significant bit, you understand. Now what we will be doing is making an array and computing all of just taking the binaries of all of them and adding how many ones they have as their bits. So what we can see here is we have already computed these four, and now we can take the reference by just taking the base and subtracting it by our current iteration. What I mean here is, for example, our current iteration is 5. Okay, this is our iteration, like you can say I, and subtracting it by base. So what is the base? The base is going to increase, like this is our base 1 2 3 for a multiple of 4, this is a multiple of 2, this is why it is called binary. So at first it will be 1, so the first iteration, and so the second iteration it will be 2 and 3, and now it's going up, and 4, and till 8 it will be going. So how it is increased when our base, like this, when our base, if you multiply it by 2, becomes equal to a current iteration we are on. So for example, for the second iteration 2 2, we updated our base by 2, like this we have done, like base is equal to I. And we are going to do the same with 4. You can just say whenever the two match, like the number for the base and the number of iteration, same is going to happen at 8. What we will do is subtract it by our current iteration, that will give us a r. For example, this was our array, so 5 minus 4 will give us the 1 location, and we have already computed 1, we already know there is going to be 1. Now let's calculate 6. 6 will have a r, 6 minus 4, and 6 minus 4 will be 2, and obviously it has one bit, so it will be added here. And for 7 it is the same. So that's it. Now let's code it down. So first of all, making an array, let's write it down quickly. So first of all, making an array for I in range, for I forgot to for I in, yeah, now it is good. So for I in range starting from 0 and n plus 1, because we want to include our last digit, and base will be starting from not 0, from 1. So for I in range we'll be starting from 1 to n plus 1, because there is, for 0 there is 0. We have already put it 0 in our list, so we don't have to uh, go again to look at it. So if base, if you multiply it by 2, becomes equal to I, the current iteration we are on, so we will just uh, make our current iteration our base. So now what we are left to do is just ar at I, our current iteration ar index, adding one significant one bit, And now what we will do is subtracting I by our base. We have already computed and we'll be using them again. And now just return uh, AR, and that's it. Let's see if this works. It works, and let's submit it. Okay, if you have any kind of question, you can ask them in the comments. And if you have any kind of question in the comments, or you can just reach me out to the my Instagram Abdullah Arshad 956, and that's it.